So, hello everyone, welcome to GeekNerd. Today we are going to solve the 14th question of the array in the GeekNerd sheet. If you want this GeekNerd sheet, then you can click the link in the description. You will redirect to this page, and you can solve. You just have to click any question, and then you have to click that link and you will redirect to that question. Okay, uh, we have solved 13 question uh, till now. So if you are solving this question and you are facing any problem, then you can click the link that is there in the Java section, and I have uploaded the solution of it in the Java. I have explained it. You will able to understand it properly if you watch it carefully. And if you are not able to understand anything, then you can comment down below, and I am watching the comments. If you have any query, then I will resolve it as soon as possible. So today we are going to solve the continuous subarray sum problem. So let's start it. So I'm increasing the font size. Okay. I hope it's visible. Uh, the continuous subarray sum. Let's read the question. Given an array, given an integer array nums and an integer k. There is a integer nums array that is given, and there is a integer k which is also given, as you can see here, right? Okay, here and here. Then return true if the nums has a good subarray or false otherwise. So what is the good subarray? A good subarray is a subarray where the length is at least 2. Okay, we have to take the subarray which has at least 2 length. That means the length of the subarray will be equal to or greater than equal to 2. Okay, and the second condition is the sum of the element of the subarray is multiple of k. That means the subarray should, like, if you sum this every element of in the subarray, then that will be the multiple of k. Okay, note that a subarray is a continuous part of array. Of course, the subarray is a continuous part of the subarray of the array. Okay, and integer x is the multiple of k if there exists an integer n such that x is equal to n into k. Okay, it's explaining what is the multiple, so you don't have to think about it. It's the general thing. Okay, so basically the question is like that. There is an integer array given and there is a k given. So we have to return true when we are able to find a subarray in the array where the length is greater than equal to 2 and the sum of it will be the multiple of k. Let's understand this question more through example. So here in the example 1, there is num. We have 23, 2, 4, 6, 7 in the array nums, and we have k is equal to 6. Okay, so if the output is true, why it is true? Because we find a subarray 2, 4, uh, and its size is 2, which is satisfying the first condition, which is the length should be at least 2. Okay, so here we have find the length of 2, and if we sum 2 plus 4, that is equal to 4. That 2 plus 4, that is equal to 6, and which is the multiple of 6. So we are able to find a good subarray. So we are returning true. Okay. Now check the second example. Second example, 23, 2, 6, 4, 7. It is returning true because the subarray is the whole array here, and when we are it's actually this size is 5, so it's greater than 2, greater than equal to 2. So first condition is satisfied, and the sum of it will be 42. So 42 is the multiple of 6, so we are returning true. Okay. Here nums is equal to 23, 2, 6, 4, 7. K is equal to 13, and the output is false because we are not able to find any subarray that is greater than equal to 2, and the sum of it will be the multiple of k, that is multiple of 13. So if you are finding if you see any subarray in the third example, then we'll not find and we are going to sum the element in the subarray, we'll not find a multiple of 13. So let's take an example. 23 2, it's 25. Is 25 is multiple of 13? No, it's not. 2 6 4 12, not multiple of 13. So that kind of we are going to find every subarray of it, and see whether the um, subarray, the sum of the subarray is equal to 13, and with that also we have to keep in mind that the length should be greater than equal to 2. Okay, so if we sum that, and if we are able to find any element that is if the sum of the element is greater than equal greater than if the sum of the element is a multiple of k, and greater than and the length of the subarray is greater than equal to 2, then we are returning true. I hope you understood the question. Let's proceed to the approach. Okay, so let's take an example. For example, I'm taking this one. Okay, let's move to the Excel draw. Okay, and here I am going to paste this. I'm going to make it big. Okay, okay. So here uh, we the what is the k value? K value is 6, right? Okay, let's k value is equal to 6. Okay, so here we are going to check whether um, we are able to find any subarray which is greater than equal to 2, and its sum is multiple of k. So what's the subarray? So subarray is a contiguous, first is a contiguous, and we have to what we say, like what the proper definition of it. Uh, Subarray is a contiguous part of the subarray, contiguous part of the array. Okay, and we have to keep in the mind that the length should be 2. So contiguous part means 23 and 2. We can take this as a subarray, right? 23 comma 2 comma 6. We can take that. 23 alone is a subarray, but we are not going to consider that because the first condition of the subarray is that uh, sorry the length of the subarray should be greater at least 2. So we are not considering the element that is alone. Okay, it's the subarray that has only one element. Okay, so here again 23 2 6 4. Okay, 23 comma 2 comma 6 comma 4 comma 7. Okay, this is a subarray. And another, like we can have 2 comma 6 also. Alone 2 we can have that, but we have a constraint of having length greater than equal to 4, greater than equal to 2. So okay, let's have, we have also 2 6 4 7. Let's have it here, 6 4 6 4 7 and 4 7. These are all possible subarray of this array which has length greater than equal to 2. Okay, so how did we find that? We are able to find it like we have iterate. First we iterate from the 0th index, and like we go till this, then till this, then till this, then till this. Like that only we have went from till this, then till this, then till this, then here till this, then here till this. So and we covered all these subarray. If we calculate sum of every subarray, huh, and check whether we are getting the multiple of k or not, then the solution, then we get the solution, right? So here, if we calculate 23 plus 2 is 25. Is it a multiple of k? No, it's not. 23 plus 2 plus 6 means it means 25 plus 6, that is 31. Is it a multiple of k? No, it's not. Then 23 plus 2 plus 6 is 31 plus 4 is 35. Is 35 is multiple of k with 6? No. 23 plus 2 plus 6 plus 4 is 35 plus 7 is 42. Is it a multiple of k? Yes, it is multiple of k. We are going to return true. We don't need to check further, but if we get any of the subarray as a multiple of k, like sum of the subarray as a multiple of k, then we are going to return true. Okay, so it is the approach. For this, what we are going to do, we are going to have a for loop. We'll have I starting from the 0 to n minus 1. Okay, and as we want our element to have the last index, so we will have the first index that is iterating from 0 to n minus 1, and we have the last index which will start from the I plus 1. Why is it that? Why I plus 1? Why not I? Because we don't want the last index to be the same element, because we don't want a single element subarray, because otherwise the condition will not be satisfied, right? So we will go I plus 1 to n minus 1, and there we will have the sum of the subarray, okay, I to j, and if we find some percentage k is equal to 0, then we are going to return true. Okay, and if we don't find any case which is true, then we are going to return false. So this is going to be our brute force approach. So let's convert this into a code. Okay, so we will have the first index, starting index from I is equal to 0 to I less than length. We will have the length as a variable. Okay, sorry. Okay, and we'll iterate till the last index, and for the last in the for the subarray, last index of the subarray, we are going to have start from the I plus 1, j less than n, j plus plus. Okay, so we got first index and last index. So we are going to have a sum is equal to, let's have a math function and assume that the function is returning the sum of this subarray, which is starting from the ith index and ending at the jth index. So sum arr, and here we will pass the array nums, and the starting index of starting index and the ending index. Okay, and if sum modulo k equal to 0, then we are going to return true, and if we don't get any case where it is true, then we are going to return false. Okay. Okay, we have assumed that sum array is returning the sum of the subarray that is starting from I and ending at j, but we have to write the logic for that also, right? So sub public static sum int sum arr int nums int I int j. Okay, and we will go from int okay, let's have this name as s, start in an e, and okay, int I is equal to s, and I go till the end, and I plus plus. Okay, let's have the sum outside as 0, and we are going to increment sum with nums I, every element in this subarray, and we are going to return sum. Okay, let's run the test cases. Okay, every test case is passing. Let's submit it. It's a easy solution. It's a brute force approach. Let's see, is it able to pass or not? No. Here the logic is correct, but we are getting time limit exit. Why is that? Why is that? Because first thing we are using two nested loop. So here it is taking big O of n square. Okay, and for this sum logic, uh, we are iterating over the subarray also. So here again big O of n, it is taking big O of n, and if we multiply it, then the brute force logic is taking us big O of n cube, which is very time consuming, right? So we have to optimize it. How will we optimize it? So if you see this logic also, so when we are like calculating the so when we calculate the sum of the first two element, we get 25 here. After adding one element, why do we need to add again the three element? We have added the first two element before. If we store it in a variable, and when the index is incrementing one, or we are adding one extra element afterward in the subarray, so do we need to calculate it again? If we store the 25 in a variable like pre-sum, then we can add in the every element, and we don't have to call this subarray again and again. Like what I'm saying is, if we have int pre-sum here, and I will initialize it as 0, or no, not 0, array of I, because we are considering array of I also. And we are going, what we are going to do in every time, we are going to use sum plus equal to array of j. So what will happen for the first two index, like it will get sum, and whenever like we are iterating, we are adding one element in the end, we are just summing in the pre-sum. Okay, we have pre-sum here. So pre-sum plus equal to array of j. Pre-sum plus equal to array of j. So what will happen here? We have 23 plus 2 is 25. We store it in the 25. As 25, we are not getting the multiple of k. We'll proceed to another subarray, and here we have 25. We'll add 6 in it. We get 31. Then we add 4 in it. We get 35. Then we add 7 in it. we get 42. And as we get the 42, which is a multiple of k, we are returning true. So here what will happen? The extra thing that we have, the big O of n, will be reduced. Okay, so because of it, will our time complexity will be big O of n square. So let's see. So what we are going to do, we are going to remove this sum array. We don't need this, and we'll have int pre sum as array of I. Hmm? And will have pre sum plus equal to array of j, and if the pre sum, or like make it as sum only, okay, don't worry. If the pre sum is a percentage k is equal to 0, then we have to return true, otherwise we are going to return false. So what happened? Okay, it's not ARR, it's nums. I'm always doing this only. Nums. Let's run it. Okay. Okay. Here all the test cases passed. Let's submit it. 95 case passed earlier. Again, we have 95 case only, and we are getting time limit exceeded. So it's not enough. We have the solution, which is big O of n square, but it's not enough. We have to optimize it more. So how to do that? Okay, let's remove this, all this, or oh, wait. Okay, let's not remove this. We just remove this one. Okay. Okay. Let's just make it like that only, and I don't want to remove it. Okay. I will just copy this and and may let's copy here also. Okay. Okay. So we have to think of different approach. Okay. Mm-hmm. So let's suppose we here I'm taking k, um I'm taking different k. So k here is suppose to 8. Let's take k is equal to 4. So for this we have 2 comma 6 is equal to 2 plus 6 is equal to 8, and which is a multiple of k. So the answer will be true. Okay. So what we are going to do here? Hmm. So hmm, hmm, hmm. So what we can do, we can have a pre-sum in every element. So like here is the 23, year 2, year 6, year 4, and year 7. So if we have a pre-sum in every element, like here with 23, 23 plus 2 is equal to 25, 25 plus 2 is equal to 27, 27 plus 4 is equal to 31, 31 plus 7 is equal to 38. This is the pre-sum, right? Particularly we want this two subarray. So if we want to find the sum of it, so we just have to um, minus minus basically what we want the sum of all this minus the sum of this. The sum of all this is equal to 27 minus 23. Okay, I have calculated it wrong, so I have to again do it. Okay, here it is 23, 25, 31, 35 plus 7 is equal to 42. Okay, if you want to calculate this plus these two, so basically what we have to do here is 31. So 31 minus 23, that is equal to 7, 8. So 2 plus 4 is equal to 8. Okay, so we can say that this is P and this is Q. Okay, so we can say that P okay, right, radius Q minus P is equal to as a P minus P Q minus P percentage K is equal to 0. That means whenever we are having a sum of sum of subarray, so we will take two prefixes. Like we have prefix. If we subtract this two prefixes and modulo k, then we are having a sum of subarray, and we are like having a modulo of k is equal to 0. Okay, so let's assume q is equal to q dash into k plus r1, then let's p is equal to p dash into k plus r2. Okay, we can do that. So if we do that and we do the modulo of k only, so here we will get q dash minus p dash plus r1 minus r2 modulo k is equal to 0. And here also we have into k also, right? Into k and modulo k. Okay, into k modulo k. So if you think like that, like as it's a modulo of it's a multiple of k, it is a multiple of k. So basically let's think like that. In the 2 table we have 6 and we have 2, and we subtract it, we get 4. Isn't it? It's a modulo of k. So as it is a modulo of k, so we are going to, if we modulo of 2, then we are getting 0. So here it will become 0. Okay, so r1 minus r2 modulo k will be 0, right? So can we say that r1 modulo k minus r2 modulo k is equal to 0, and we can say that r1 modulo k minus r2 modulo k, like r1 modulo k is equal to r2 modulo k. So what I'm explaining you is that suppose there is we have a element here, like let's take this example only, and we are doing modulo k of every element, and we are getting here as 3 and here as 3. Then that means the array in between is the good subarray. Why? If we sum it and we do the modulo k, we'll get 0. Are you understanding what I'm saying? Okay. Let's think in different way. Okay. Okay. What is that? Here, I'm taking the same example. Okay. Let's do this only. Okay. Let's do this only. And we have k is equal to 4, right? So when we do 23 modulo 4, what we are getting? 4 into 5 is equal to 20, here 3. So can we say that, okay, sorry. Can we say that here, if we reduce 3 out of it, then it will be the multiple of k, right? There is a extra 3. So we can say that like 20 into 4 plus 3 is equal to 23. So not 20 is 20 into, sorry. Uh, sorry. There is some element which is multiple. So we can say 20 plus 3 is equal to 23, right? So here it is the modulo of it. Okay. So we are having 3 extra. That's why we are not having. Okay. So then we are adding it and we get 25. Okay. So when we do 25 modulo 4, we are getting, so what is the modulo of it? It is 1. So what does it means? We have, if we have 24 plus 1, that is equal to 25, and 24 is the modulo of k. There is 1 extra in it. Okay. If we have 24 and then 24, then we will have a module. We will have a multiple of k. Okay. Let's add another one, that is 6. That is 31. 31 modulo 4. Okay. So here we are getting the, again we 4 into 7 is equal to 28. So 28 plus 3 is equal to 31. So we are getting 3. So when we are here, we are getting, if the sum of the subarray is 28, then that subarray will be good subarray. Okay. So it will be the good subarray, right? But here we have 3 extra and here we have 3 extra. When we are going to subtract these two, right, the extra part will be removed. Okay. So the in between subarray sum will be having no remainder. Are you understanding what I'm saying? That is what I did here also. Okay. Understood? So what I did was, with this equation here, when we are like subtracting 31 minus 23, as we know, like 31 minus 23 is 8, and which is the modulo of k, that is modulo of 2 is equal to 0. So when we assume that there is a remainder, so like we did that, like 28 plus 3 is there, and minus 20 plus 3 is there, and out of which we are doing modulo 2 to get 0. And if we subtract this, as we can as it is a module, as it is a multiple of 2 only, sorry, as both of these are multiple of 2 only, so we can say 2k1 plus 3 and 2k2 plus 3, okay, modulo 2 is equal to 0. So that's why when we are doing this k1 minus 2k2 and modulo 2, so as these are multiple of 2, so we get 0 here, and we get r1 is equal to r2, and we get that. Okay, okay. Of course, the remainder is there. So R1 modulo K will be R1 because there is no multiple of it is there, and R2 modulo 2 is R2. So R1 will become R2. Okay, I think I make you more confused here. So let's do it again. What I'm saying is there is a there is when we are adding it like 1, 2, 3, 4. Okay. So here and here. Okay. So what is the sum of it? 1, 2, 3 plus 4. So 6 plus 4, 10. So here the sum is 10, and here the sum is 3. When we are 10 minus 3 doing it is 7. So basically what is happening? We are considering these two subarray. Okay. So 3 plus 4 is 7. So suppose the k is equal to 7, then the answer should be like this should be the answer. So let's assume that it's a p and it's a q. Okay, when we are doing p so q minus p is modulo of k is equal to 0. So the q, let's assume q is equal to q dash modulo k plus plus r1, and p as p dash modulo k plus r2. Okay, so basically it will be lesser than k. So if we can say that it is the q1 is multiple of k, and q2 and not okay, that's why I'm having error. It's multiply, not modulo. Sorry, it's multiply of k and multiply of k, so it's a multiple of k. Previously what did I say? I'm thinking of something and writing something. Okay, no, previously I said it correctly. Okay. So so q1 into k and q, so it's a multiple of k. Okay, if there is a two multiple of k, and when we subtract it also, it will become the multiple of k only, right? So here what we are doing, q1 into k plus r1, p1 into k plus r2, and if you do the whole modulo of k, that will be 0. Okay, so what we can do, we can divide this q1 into k minus q2 into k modulo k plus r1 minus r2 modulo k. So here it's a multiple of k, and we'll get the whole as a multiple of k only, multiple of k. And if we do modulo of k in multiple of k, so suppose 4 modulo 2 will be 0, right? So here the whole element will become 0. So we get r1 minus r2 modulo k is 0. So if we do r1 modulo k minus r2 modulo k is equal to 0, and r1 modulo k will be r only because we have removed the multiple of it. So it will be less than k only, and r1 minus r2 is equal to 0. So r1 will become r2. Okay, we are getting r1 is equal to r2. before that we have assumed that q and p is a like q minus p is a modulo of k, and whenever we find this kind of condition, that means the subarray is a good subarray. Okay, it's satisfying, and the sum of it will be the multiple of k, right? So whenever we are doing modulo of q, we get r1. When we do the modulo of p, then we'll get r2. So whenever we'll find the subarray, like pre-sum of every index, and when we get the one pre-sum that we have, we if we find the index, the pre-sum of two index is equal, then that means there is a good subarray. Understood? Okay, let me explain you with the dry run. Okay, so here we have 23, right? Here we have 23, and suppose k is equal to 4, and we know these two will be the sum. These two will be the good array. If we consider these two as a subarray, then it's a good subarray. So we'll do 23 uh, percentage k. So 23 percentage k is 3, because 20 is the multiple. Okay, then we'll sum 23 plus 2, 25. Okay, 25 percentage k, that will be 1, then plus 6, 31. 31 percentage k, that will be 3, then 35 percentage k. So or we can do that also ki, as this is the remainder of it, so we can just do that like 3 plus 4, 7 percentage 4, that is 3, or we can do like 35 percentage 4, we'll get 3 only, because 32 is the multiple. Okay, so here we'll get the 3. Okay. Okay, I did wrong here, I think. 31 percentage, now it's right. 23 plus 2. Okay, then okay. Oh, it's okay. We are getting 3. It's correct only. 3 plus 4, 10. 10 percentage 4, that will be 2. 2. Because 2, 3, 2, 6 is 8. 8 plus 4, 12. 12 is also a multiple of okay only. Okay. So as we are getting 3 here and 3 here, so there if there any and in any two number is equal, then that means there is a subarray. Okay, that is the simple logic here. Okay, I hope you have understood these things. So let's start this. Have this logic. Add this logic. Okay. Okay. Before that, I have missed one thing. Here we are not checking that the length of the subarray is greater than equal to 2 or not. So we have to check it also, right? So if I consider this only, suppose this is not there, only this much is there, so we have 3 3 in the adjacent, right? Okay, the calculation will be changed. Okay, let have this example also. 264, not 264. Let's have it. uh no, don't realize. We have 3 1. Okay, let's have 1 2 3. Let's have a simple example, and k is equal to 2. Huh? Okay, not uh, this will not work, right? Mm. I have to think. Okay, 1 4 6. Okay, and k is equal to 4. This will be a good example. Okay, so hmm. So here the answer will be false, because even if we have multiple of k, but we can't choose a single subarray that has single element, right? So here we are getting percentage 1, here 0, here 2. Okay, here also I'm getting the same thing, right? Okay. Um, I want it like 0 0 in adjacent. Mm, okay. Suppose I'm saying it like, if we are getting a equal element in the adjacent, that means that means that means we are not taking a subarray of greater element. So when we have a 3 here and here 3, we are having 3 here. So that means what is the meaning of it? We are taking here it is the I, here it is j. The subarray will be I plus 1 to j. That is the meaning of it. Because this we are taking it as a q, and here we're taking it as a p, and p minus q is this array, right? So whenever the j minus I should be greater than 1, it should not be less than 1. Okay, or of course it won't be 0, it won't be 0, but we shouldn't have other than this. Okay, so that will be the condition, j minus I should be greater than equal to 0. If it is not, then we have to check further. Okay, so that condition we have to apply. So here for this we have to store index with the modulos. So what we are going to do, let me write the pseudo code of it. So let have int presum is equal to 0. Okay. Mm, okay. And we are going to have hash map, because hash map hash map because we want to store the value, the modulo value with the index also. So we'll iterate I is equal to 0 to n minus 1. Okay, and have presum plus equal to um, array of I. Okay, and and if we find um, map contains key, because we are going to store the modulo value as key, so contains key as the okay, and we are going to add presum as a modulo of it, right? So we have to do modulo of. Okay, or what we can do is we can first add it, and we'll do presum is equal to presum modulo k. Okay, so if you find the presum here, or like presum here, we can directly do modulo of it. Then if you are finding it, then we'll check whether the key of it. So the map dot get presum percentage modulo is equal to sorry, presum into modulo minus I is greater than 1 or not. If it is 1, greater than 1, so we are going to return true, and in the end, if you are not also finding it, we are going to add it in the map dot put, and we are going to add the prism modulo k, comma the ith index, and here we are returning false. That will be the approach, and that will be the pseudocode. Let's understand. Let's write this code. Okay. Mhm. So here I'm minimizing it. Mhm. So we, what is happening here? Okay, wait. I'm waiting for a second. I think I'm clicking something first. So, okay, now uh, hmm, what we were doing, we are going to first have prism. So int prism is equal to 0. Okay, int then we are going to have a hash map integer comma integer map is equal to new hash map. Okay, we'll iterate over the map. So I less than n. First we have going to have n. So n is equal to nums dot length I plus plus, and what we are going to do, like we are going to add prism plus equal to nums of plus equal to nums of I. Then we are going to modulo it also. It's better to do modulo before prism modulo. Okay, so we'll get the modulo of the prism. Now we'll check, are we getting modulo value in the modulo related value, or we can have no, it's good. We should do like this only. Contain keys. Okay, and we'll have, if it is containing, that means there is a subarray which is if we sum it, then we are getting the multiple of k, but we have to check whether the subarray is greater than the length of the subarray is greater than 2 or not, greater than equal to 2 or not. So we are going to have int j is equal to map dot get prism. Okay, and we'll check whether j minus I is greater than 1 or not. If it is greater, then we are going to return true, otherwise we are not. And we are going to add map dot put prism comma I, and in the end we are going to return false. Okay, so what the error? Okay, it's not contain keys, it contains key. Okay. Hmm. Okay. We are getting some errors. So why is that? Let's see. What did I make wrong here? Okay, we are adding the nums I. Okay, we are doing modulo. Okay, if the map is containing the key, that means there is a subarray, and we are getting the, okay, the last index is I, and the first index is j, so that's the difference. Okay. Okay, let's see. Okay, the test case is passing. Let's submit it. Hmm. We are getting another error. That means I did something wrong. The I minus j is greater than 1, then only we are going to return true, otherwise we are not. But okay, what's the issue? So here we should get 7. Okay, let's calculate it. Mm, Prism plus equal to nums I. Okay, we are reading nums I. Prism is equal to prism modulo k. Okay. Map dot contains key. अगर if we have prism before, that means we are going to have this and return true. Okay, but when if we are not getting, then we just have to add and proceed further. Mm. Okay, for this 232466, the case 7. So 23. Well, if we find the modulo of it, then here 2, 4, 1, 2, 4, 1. Let's write this. 2, 2, 4, 1. 1 plus 6, 7 is equal to 0. Okay, I got it. I got it. Actually, I got it. There is a case where if we have like this also, here we get 0, right? Here we get 0, and that means if that means if we add all these element, then we the modulo of it is 0. The modulo of it is 0. That means it's a multi. If we consider this subarray and we do modulo, like if we consider this subarray, it is a good subarray. And if we add it and do modulo k, that is coming 0, but we don't have another 0 here, so that's why we are having error. So what's the solution of it? If we are getting 0 here, that means we can directly return true, but there is this case. What if there is a 7 in the front, and other than that there will the we are not getting any subarray, which is let me have an example here. Okay. We have a 7 here and comma 1. Okay, and k is equal to 7. We are getting modulo is equal to 0, and here we will get modulo as 1. Okay, as we are getting 0, that means this is a good subarray, but it's not greater than equal to 0, so we will not consider this. Okay, so whenever we are getting 0 at the first, will not consider. Okay, if we have 0 in the end, like if we have 3 comma 4 comma 1, so here we are getting 3, here we are getting 3 plus 7 7, modulo 7 is equal to 0, and we are getting 1. So as we are getting 0, so if we consider this 2 also, that means it's a good subarray, right? And it's greater than equal to 0 also, so we can consider this subarray and we can return true. So either we can do that like if we are getting um, some pre-sum is equal to 0, and if I is not equal to 0, then we have to return true. That might work. Let's write it and let's see if it is passing or not. Okay. If pre-sum equal to 0 and I not equal to 0, then also we are going to pass. Okay. Let's submit it directly. We are getting error again. Okay. Okay, let's examine these things also. We are getting 0, but for this case now, it's true. Oh, it's true. Actually, it's true. And we should get 5 plus 2 through 2 plus. We should get true for my solution also. But why it's not true? Am I doing something wrong? Hmm. Let me check. Okay. Okay, sorry for this. I am getting so many errors. Why is that? I don't know. But okay, here we getting 2, here we getting 2, here we getting 2. Okay. Huh. Okay, I got it. We have to change the map whenever we are not getting. Otherwise it will update every time, right? Okay. Okay, this is the small error that we have. Okay. I have to be careful. Okay. Writing the script. Okay, submit. Now it will work. I hope I don't get any error. Okay, it's passed. Why is the error? Because when we are getting 222 and we are updating it every time, so this 2 is not considered. Like why we should consider this 2, and after that we have to consider this 2, right? So every time it is updating the map, so that we are checking first this 2, then this 2, and then we are checking this 2, so we are getting false. But okay, we have fixed this issue. Okay, it is solved, and we can do like this also. Or what we can do is initially we will fix map dot put um let's have a -1 index 0, or it's opposite actually, 0 comma -1, and if we run it, it will pass and we submit. I think it will be accepted. Okay, it is accepted, and the solution is completed. It took long time because I was debugging in the between also, but I hope with the debugging you are able to understand like what kind of error it might happen if you write wrong code. Okay, so I hope you have understood. If you like the video, then please click the like button. Comment in the video if you have query and feedback, and subscribe my channel to motivate me, and it will help me to make more video like this. So thank you. I'll meet you in the next video. Till then, bye.